Gigabyte have released their new 17-inch version of the Aero laptop, but does a larger machine provide better cooling? I'll be testing out thermals in detail and pushing the 8-core i9 CPU to the limit so we can see just what it's capable of. The Aero 17 laptop is available in different configurations. My model has the overclockable 8-core Intel i9 9980HK CPU, Nvidia RTX 2070 Max-Q graphics, and 16GB of memory running in dual channel, so expect different results with different specs. It's also available with an i7 CPU and different graphics options. You can find examples and updated prices linked in the description. The cooling design is similar to the new Aero 15 I recently tested. On the bottom, there's a nice large mesh area for intake. There's also some air intake vents found above the keyboard, and air also comes in through the keyboard. Air is exhausted out of 4 vents, 2 on the back and 1 on both the left and right side towards the back. On top of that, Gigabyte have also stated that they're using Thermal Grizzly Hydronaut thermal paste, so that should be better compared to many others out there. In terms of heat pipes, we've got 2 shared between the CPU and GPU, and the design looks the same as the 15-inch model. However, the heat sinks look a bit thicker due to the extra space available with the larger 17-inch chassis. The Gigabyte Control Center software allows us to set the CPU between 6 different levels of power, and the GPU between 2 levels, as defined here. Throughout this testing, I've tested the stock settings with the CPU at level 2 and GPU at level 0 with the fans on the normal profile. Here's what the default fan curve on the normal profile looks like. So we're not even getting to 70% max speed and expect it to run warmer but quieter as a result. The gaming profile boosts the fan speed a bit, and we also have the option of customizing the curve for optimum performance. You can also quickly set the fan speed to maximum by pressing the function and escape keys. And when I've tested the fan at max speed, I've also boosted the CPU to level 5 and GPU to level 1 for highest levels of performance. So up to 80 watts on the CPU and 90 watts on the GPU, thermals permitting of course. Thermal testing was completed in an ambient room temperature of 21 degrees Celsius, so expect different results in different environments. At idle, it was a little warm. However, in quiet mode, the fans were completely silent, so this is expected. The rest of the results are from combined CPU and GPU workloads, and are meant to represent worst-case scenarios as I ran them for extended periods of time. The gaming results towards the upper half of the graph were tested by playing Watch Dogs 2, as I find it to use a good combination of processor and graphics. The stress test results shown on the lower half of the graph are from running the AIDA64 CPU stress test with only the stress CPU option checked, and the Heaven GPU benchmark at max settings at the same time to fully load the system. I'll start off by noting that the CPU was thermal throttling at 90 degrees Celsius, which we can see happening in many of these tests. Personally, I think this is a good thing. Gigabyte are capping the thermal limit to prevent it getting too hot. And as we'll see in the next graph, performance is still great. There was some thermal throttling on the GPU while gaming at stock when it averaged 86 degrees Celsius. But that was the only instance and was tested with the normal fan profile. Simply swapping to gaming or above would remove it. By setting the fan speed to maximum, we're able to improve the GPU temperature despite the GPU power limit raising from 80 to 90 watts. However, this action alone wasn't enough to remove the thermal throttling on the CPU. Once we undervolt the CPU, no changes were seen in terms of temperatures while under stress test. However, this was enough to remove thermal throttling while playing this particular game. As thermal throttling was the limitation while under stress test, I added in a cooling pad. And we saw this drop temperatures by 6 degrees and remove thermal throttling. The thermals were now under control, so we're in a place to attempt some CPU overclocking. And as this requires more power, more heat is expected. So the overclock took us back to thermal throttling while under stress test. While gaming, the overclock rose the CPU temperature back up by 7 degrees Celsius. However, it wasn't thermal throttling under this workload. These are the average clock speeds for the same tests just shown. We're seeing the lowest clock speeds with the normal fan profile, as thermals were the key limitation at this point. By increasing the fan speed, we have more thermal headroom, which is why I also boosted the CPU and GPU power limits here, and this is why we're getting higher clock speeds. The CPU undervolt improved performance further, though more so for the stress test result compared to gaming. The cooling pad made no major difference in terms of performance. While the 9980HK has an all-core turbo boost speed of 4.2 GHz, I found mine would cap out at 4.1 GHz. And this was hit with the cooling pad both under stress test and while gaming. By overclocking to 4.4 GHz, we're almost averaging this while gaming. So I probably could have pushed even further there, an excellent result. While under stress test, the thermal throttling was back with the overclock. However, I think a 4.25 GHz average on 8 CPU cores is an excellent result. These are the average TDP values reported by Hardware Info during these same tests. We can see the GPU power limit raise up from 80 to 90 watts by going from GPU level 0 to level 1, as per the green bars. While the CPU is at level 5, it has an 80 watt power limit. However, we never get close to this under these combined CPU and GPU tests due to thermal throttling. This means that power limit throttling was never an issue in these tests, so there's that. The highest I saw was a 69 watt average once overclocked and undervolted. Higher was not possible due to thermal throttling, at least in these workloads. These are the average CPU clock speeds while under a CPU only workload. We're able to get higher speeds than what was just shown before as the GPU is sitting idle now. The top bar is at stock with the highest level 5 limits set in the Gigabyte control center. In CPU-only workloads, we're averaging close to the 4.2 GHz all-core turbo speed of the 9980HK in this workload, with over 4.5 GHz being hit once overclocked. When we look at the average CPU TDP, we can see at stock we're hitting the 80 watt limit defined by level 5. However, undervolting the CPU allows it to perform slightly better while using less power. Alternatively, instead of undervolting, I could manually raise the power limit further to achieve the same small clock speed boost. But instead, when combining the two, I only saw slightly more power needed for quite a large clock speed boost to above 4.5 GHz. More power equals more heat, so with the overclock under a CPU-only workload, we're actually at the 90-degree thermal throttle limit. Again, the undervolt only gave the best temperatures as it lowers the power draw, while more power from boosting the power limit equals more heat. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks here. Just for reference, your typical i7-9750H seems to be around 2800 in a good machine, while I managed to push the i7 in the Aero 15 to around 3100 points for comparison. This means we're seeing a 35% higher score in this test with the Aero 17 and 8-core overclocked i9 CPU compared to the i7 in the Aero 15. And I already consider the Aero 15 score as one of the highest I've ever gotten from the i7. The single core clock speed was higher as the i9 can go right up to 5 GHz at stock while under a single core workload, thermals permitting. So how do these performance boosts actually translate into games? I've tested a few games both at stock and with these custom changes in place to see what performance increases we can expect. In Battlefield 5 at maximum settings, we're seeing a 6% improvement to both average FPS and 1% low performance with these changes in place. In Shadow of the Tomb Raider with the built-in benchmark at highest settings, there was a larger difference. Almost 9% higher average frame rate was happening with these tweaks. In Far Cry 5 with the built-in benchmark at ultra settings, there was almost a 7% improvement to average FPS with the changes in place, though there was less of a difference when it came to 1% low performance. As for the external temperatures where you'll actually be putting your hands, at idle it was in the mid-30s in the center, just a little above average. While gaming with the fan on the normal profile, it's getting to the mid-40s in the center, so on the warmer side, and up to 60 right up the back, which was hot to the touch. Simply by setting the fan to maximum speed, the hotspots dropped by around 10 degrees, and the keyboard was much cooler to the touch. Here's what a combined CPU and GPU stress test looks like with the fans at maximum, but this time with the CPU and GPU power limits boosted, and it felt fine due to the fan speed. As for the fan noise produced by the laptop, I'll let you have a listen to some of these tests. At idle with the quiet profile, it was completely silent. However, I could hear some subtle coil whine, though that vanished with any level of fan speed. With the normal fan profile, it's actually fairly quiet compared to most other laptops I've tested, so you do have the option of running quieter for less performance. And then the gaming profile rose that up a bit, but still lower than most other gaming laptops I've used. With the fans at max speed, it is quite loud. However, I think this is a good thing. As Gigabyte let us adjust the fan curve with high levels of granularity, it means you have the option of customizing it to find a sweet spot that works best for you. In my opinion, this is an advantage compared to others that lock down control. Overall, I'm quite impressed with these results, keeping in mind these are essentially worst case scenarios that we're looking at. While this is the first time I've ever tested the i9 9980HK CPU, the temperatures were always kept under control regardless of my modifications, as Gigabyte are capping the CPU temperature to 90 degrees Celsius. They could of course done what Dell did in the G5 and allow it to run up to 100 degrees, and while this would improve performance a little, I'm personally happy to take the hit so temperatures don't go above 90. Even at stock, simply by raising the fan speed, we're able to get pretty good clock speeds, especially considering these were over 8 cores, while some simple undervolting improved things further. In my tests, just by undervolting with the raised fan speed, even under combined CPU and GPU stress test, we're almost at 4.1 GHz on all 8 cores, which I think is quite impressive when compared against most of the 6-core i7 machines I've tested. As you'd expect, with 8 cores and high power limits, thermals were the limitation, so using a cooling pad was able to help out a fair bit. While I haven't tested out the i7 in the Aero 17, based on these results, I'm assuming it should handle it well. In future, I think if Gigabyte start undervolting out of the box, like we're seeing Acer do in the Helios 300 and Razer do in the Blade Pro 17, then I think it would be in great shape. Ideally, if the AI software controlled this dynamically within a known stable range, it could make it much more useful. The 230 watt power brick that Gigabyte include with the Aero 17 appears to be adequate for these specs. I was seeing some drain during my testing, but it would stop at the 95% mark, which is pretty standard behavior. It never dropped further. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results, primarily the temperature of the room you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements, so don't just blindly copy my settings and do some testing to find out where your stable point is for best results. It may be possible to further improve temperatures by swapping the thermal paste. However, as this is a review unit that I have to send back, I'm not able to change the paste. Otherwise, the next reviewer will unknowingly report different results due to what I've done. We do at least know that they're using somewhat decent paste here anyway. Undervolting, boosting fan speed, increasing power limits, or using a cooling pad are much easier for most people to do anyway. And as we've seen, these modifications did help improve performance of the new Aero 17 laptop. Let me know what you thought about the thermals and performance from the new Gigabyte Aero 17 laptop down in the comments. And if you're new to the channel, you'll definitely want to get subscribed for the upcoming full review video.